All types of pneumatic changeover thermostats are extremely expensive. Often the only problem with the changeover thermostat is that the changeover point is drifted out of range, and consequently you remain in the same mode continuously, day and night or summer and winter, and that certainly is a failure in operation. This changeover board will show you a simple method of adjusting the changeover point back to original design and also calibration for both modes of operation. It will save you a significant amount of money and time. This is an actual thermostat calibration board. This is the calibration board and changeover design to calibrate thermostats accurately without unnecessarily replacing thermostats. It has been used to calibrate thousands of thermostats, helping customers to avoid hundreds of thousands of dollars in replacement costs for day, night, and summer winter thermostats. The purpose of the calibration board. The board allows both the temperature set points and the mode changeover set pressures to be calibrated by safely simulating operating conditions of the HVAC system. There are two common applications. The day-night systems. Some HVAC systems change the main air pressure to switch thermostats between daytime and nighttime temperature settings. Summer-winter systems. Some systems, such as induction unit systems, change the main air pressure to switch between summer and winter operation. Depending on the control valve and damper, the thermostat may need the change from direct acting to reverse acting or vice versa. In both applications, the thermostat must be properly calibrated for 1. The temperature set points, 2. The correct changeover pressure, and 3. The correct direction of operation for each mode. Thousands of pneumatic thermostats have been discarded when a relatively simple calibration procedure could have corrected the problem. This particular setup is configured for a Honeywell TP971, a thermostat commonly found in schools and other institutional buildings. The tubing connections shown are connected to the thermostat backplate. Important to know, the building's requirements. Before performing calibration, the higher mode pressure must be safely available at the calibration board. Do not assume that a particular pressure represents the day-night or the summer-winter. For example, the day-night mode main air pressure may be higher or lower than the night mode pressure. The winter mode pressure may be higher or lower than the summer mode pressure. The pressure relationships can vary from building to building, even when the same manufacturer and thermostat model are used. The design pressures for different modes may also vary. You must know the specific operating requirements of the building and the HVAC system they're controlling for before beginning calibration. Connect the main air and the branch lines to the appropriate thermostat backplate connections on the calibration board. The example shown is configured for the TP971. With the system main air safely established at the required high pressure, remove thermostat from the wall and install it on the appropriate backplate on the calibration board. Connect the main air and the branch lines to the corresponding ports that serve the thermostat at the wall. Adjusting the changeover point. Number 1. Adjust the thermostat's day setting to a temperature above the room temperature. Number 2. Use the calibration board's pressure-reducing valve, the PRV, to vary the main air pressure between the established day and night pressures. Number 3. Observe the branch pressure. The branch pressure for a direct-acting thermostat should be lower for days than nights. If it is not, adjust the thermostat settings until the correct response is obtained. Number 4. Slowly increase the main air pressure from day mode pressure toward night mode pressure. Number 5. Observe the point at which the branch pressure suddenly changes. This is a changeover pressure point. Number 6. Adjust the changeover pressure to required value, normally approximately midway between the established day and nighttime main air pressures. The changeover point varies considerably between manufacturers and even between models from the same manufacturer. However, the changeover function can generally be tested and calibrated. The method of calibration varies with models. Day-night temperature calibration, 1 dial to adjust. Calibrating day settings. Number 1. Set the main air pressure to the day mode pressure. Number 2. Measure the temperature at the thermostat. Take care not to influence the thermostat with your body heat or your breath. Number 3. Determine the valve or damper's required stroking pressure range. Number 4. Turn the thermostat setting up and down to observe the branch pressure. to respond through the appropriate range from zero pressure to the main air pressure. Number 5, set the dial to the actual room temperature. Number 6, adjust the thermostat so that the branch pressure is approximately midpoint of the valve or damper's stroking range, or as required by the specific manufacturer. Number 7, carefully breathe on the bimetal element to verify that the branch pressure responds in the correct direction. Calibrating the night setting. Number 1, set the main air pressure to the night mode pressure. Number 2, turn the thermostat dial up and down and verify the branch pressure responds through the appropriate ranges. Number 3, set the dial approximately 10 Fahrenheit degrees above the actual room temperature or to the required setback differential. Number 4, adjust the branch pressure to approximately midpoint of the valve or damper stroking range, or according to the specific actuator requirements. Number 5, carefully breathe on the bimetal and verify that the branch pressure responds in the correct direction. Number 6, turn the dial to the desired daytime temperature setting. The thermostat should now be calibrated so that when the thermostat system changes to night mode, the thermostat will control to approximately 10 Fahrenheit degrees lower than the daytime condition, assuming that is the required building setback. Day-night temperature calibration, 2 set point dials. For thermostats equipped with 2 separate day and night set point dials, follow the daytime calibration procedure described above and then repeat the appropriate procedure for the night setting. Verify both settings independently under their respective main air pressures. We have the flow meter on the calibration board that allows us to show the air consumption of the thermostat through the 5/1000th of an inch orifice that provides the upper chamber of its relay. Final caution, never change or simulate the main air pressure without understanding the effect it may have on the building's HVAC system. Incorrectly applying or changing supply pressure can cause unintended operational problems with the valves, dampers, heating, cooling, and ventilation equipment. The calibration procedure should always be based on actual design and operating requirements for the specific building, thermostat, actuator, and control system. A thermostat appears to be defective may simply be out of calibration. Before replacing a pneumatic thermostat, verify its temperature, calibration, branch pressure response, and mode changeover pressure. In many cases, proper calibration can restore the thermostat to reliable operation and eliminate the requirement to unnecessarily replace it. On our website, apscontrols.org, there's an article titled Fighting Climate Worry. Within that article are links to 2 reports that are highly significant when considering the future of today's children. The first is a BBC report indicating that more than 50% of children are regularly worried about climate change. The second is a Stanford University report projecting that the world could exhaust its economically recoverable fossil fuel resources within the lifetime of the children living today. These findings underscore the importance of taking climate change challenges seriously and pursuing practical, effective solutions. Just as importantly, we need to demonstrate that meaningful action is being taken, helping to reduce the anxiety many young people feel about the future. With respect to controls logic and energy conservation, it is important to understand that no solution can be applied everywhere. What we are really teaching is comparable to teaching someone how to play chess. We can show you the moves and strategies that have been proven successful in addressing conservation challenges in the past, but we cannot predict every situation you will encounter in the future. For that reason, I encourage you not to simply memorize the concepts presented in the APS training manual, instead strive to understand them deeply. A thorough understanding transforms information into a practical tool that can be applied to new and unforeseen challenges. As Albert Einstein famously observed, information is not knowledge. Information alone has limited value. Knowledge is gained when information is understood and can be applied effectively in the real world. Thank you very much for your efforts with respect to climate change, and I believe that collectively, with everybody trying, we can make a major impact on the threat to the children's future.